Hello everyone, welcome back to the channel. Today we are going to do a end-to-end data analytics project. We will be using a Kaggle API to download the dataset from Kaggle using Python. Then we will load that data into Pandas, and then in Pandas we are going to do some data cleaning. We have some dirty data, we have to clean it. We have to create some new columns. So we will do some kind of processing. We will load the data into SQL Server, and then I have designed some 5 to 6 questions based on that data. We are going to solve those SQL questions. Okay, so if you are a data engineer or data analyst or aspiring to be one, this project is going to help you. I will share all the codes, everything on my GitHub. So I will share the link so you can follow along with me. I will explain everything step by step. So let's get started. So first of all, to use Kaggle API, what we have to do, we have to read the Kaggle documentation for public API. Okay, so this is the documentation. I will share the link. You can read it, but I will quickly show you what you need to do. Okay, so you go to kaggle.com. Okay, and if you don't have a profile on Kaggle, create a profile. Okay, sign up, and then go there and click on settings. If you go down in settings, there is a API option and you say create new token. Okay. So you click on create new token, continue, and it has generated a token for you, which is a kaggle.json file, right? So if you look at the documentation here, it is saying ensure kaggle.json is in the location. So this is my home directory. Within my home directory, there will be a folder .kaggle, and there I have to place this file kaggle.json. Okay. So what I will do, I will go to the downloads, take this file. Okay, this is my kaggle.json file, and I will go to my home directory. My home directory will be in, if I go to C drive and then users and then Ankit, and if you see here, there is dot kaggle folder. So we need to just place this file. I'll delete and place this file. Okay, so this is my kaggle.json file. Once this is done, you have to get the link of the dataset that you want to download. So we have a retail orders dataset. I will take you through the dataset later, but this is the link that we have to use. Okay, so this is the person who has uploaded the dataset. I have uploaded this dataset, and this is the name of my dataset, right? Retail orders. So I'll just copy this. Okay, and this will be used to download the dataset. Now before I go there, I will be using Anaconda Navigator, and I will launch the notebook. So I will use Jupyter Notebook to do my all my Python work. Okay, so I've already launched it. So if you go here, home, and in my documents, I have created a SQL plus Python project here, and you can create a new file. So you can create your folder and create a new file. I have already created a file with some comments. I will use it, so I will just directly click on it. Okay, so this is all we are going to do. So we are going to do a lot of operations, and we will learn a lot about pandas and then about SQL. Okay, so let's get this started. So first thing is, we have to have the Kaggle API, the library. So you have to say pip install exclamatory mark pip install Kaggle. I have already done it, so I'm not going to run it. But you have to say import Kaggle, right? Once you do it, now you can run a API call to download the dataset. Okay, so I have the command ready. So this is my command. I'll just take you through it. So I'm saying Kaggle datasets download, and this is my URL, right? This is my retail orders URL. This much after dataset, this much you have to pick. And here I have to download the file. The file name is orders.csv. Okay, so this is the command we have to run, and I'm just execute this cell. So I've executed this cell. It says it is downloaded. Downloading orders.csv.zip file. So if I go to SQL plus Python, my folder, you see this file is created. Orders.csv.zip. So we have downloaded from Kaggle to my local system. Right? Now next task is, so this is done. Download dataset from Kaggle. This is done. Okay, I'll just place it here. Okay, now if you see, this is a zip file, right? This is a zip file. If you see, so what I have to do, if I go inside, there is a orders.csv file, so I have to extract the data from orders.csv.zip file. So for that I will use the zip library. Okay, so this is the code. I'll just take it again and show you. So I'm importing this library called zip file, right? And then i'm I'm initiating a method where I'm loading the file basically. So this is my file orders.csv.zip, right? This is the file that I need to extract. And then I will say extract all. Now in extract all, you can give path. If you don't give path, it will extract on the same location where your zip file is, right? Now currently my this file, my Python file, this is my Python file, right? And this file are on same location, so I don't have to give path. If your zip file is on some other location, you can give the full path here, c users or whatever, right? And again I am just doing extract all, so that on the same location it will extract the data and then it will then close the file. So this is done. If I go to my this folder again, you see orders.csv file is there. Okay, so our first task is done, to download data from Kaggle and then extracting the data from zip file to a CSV file. Okay. Okay, so now the file is there in my local system. I can read directly in my pandas data frame. So what I will do, I will use pandas library, import pandas as pd. If it is not there, again you have to pip install pandas in your system, right? So I'll say import pandas as pd, and I will say df dot pd dot read underscore csv, because this is a csv file and this is my orders dot csv, right? So orders dot csv is there in the same path where my Python file is, so I don't have to give path. Otherwise you have to give the path as well, right? And let's look at the data. Df dot head, let's say 20 records I want to see. Okay, so this is how my data looks. I have order id, order date, all the columns are there. Now the important thing to look here is the ship mode. In ship mode, if you see, there are some not available, right? Not available, there are some unknown values, so we have to fix these values because we want to consider them as null. Okay, in pandas they are represented as none, right? So what we want to do, all these values, not available, unknown, these values we want to consider as null, right? Not these not available or these strings, right? So for that, what we will do, so first we will do how many different kind of values we have in the ship mode column. So I will say df and ship mode, right? And I will say unique. So this will give me distinct values available in this column, ship mode column, right? So let me correct the spelling, ship mode. Okay, so if you see, we have second class, standard class, not available, unknown, first class, none. This none is fine, none is treated as null, right? But these values I want to treat it as null. So for that, in pandas, if you press shift tab, you will see all the options, right? And I will use this option of NA values, right? I'll just copy this, right? And I will say comma, and I will pass these two values. So what it will do, these values will be treated as null. So whatever values I pass to this argument, so when it is reading, these values will be treated as null. Okay, so I'm going to read it again, right? And check the unique values. If you see, all those values are treated as none now or null, because we don't have unknown or not available in the data now. Okay, so this is the first thing that we wanted to handle. Now second thing is, if you see here, when I pass the column name, right, I have to give a space in between. The S is capital, M is capital, right? This is not a good practice. Ideally the column name should have been ship underscore mode, which means that everything should be in lowercase and there should be underscore, not space, right? So we will fix the column names of this data frame now. So what we will do here, if you look at again df right? So there are many columns: order, date, subcategory. So we have to basically rename these columns. So one method is this: I will say df dot rename, and I will pass a JSON that I want to rename. So I will say columns equal to, I want to rename, let's say, order ID to order underscore ID, right? And let's say I want to rename city to small case city, right? This is what I want, these two columns. So if I run this now, you will see that order ID is fixed now, right? It is renamed and city is also renamed. But that way I have to pass all the columns, right? There are 15 columns around. I have to pass all 15 columns, which is not a good way of doing it, right? So we will do some other way. What we will do, we will extract all the columns. So we can see all the columns using df dot columns, right? So it will give me a list that these are all the columns. Okay. Now I can convert it to a string object, and and string object, list of string object, and apply the string function. So for example, I can say dot str dot lower. What it will do, each value it will convert it to lower case. So if you see, everything is converted to lower case, and I will assign it back to the df dot columns. Okay. So if I just check again df dot columns, you will see everything is in lowercase. Second thing is, we have to replace spaces with underscore. So again, I will use replace function of a string, and I will say convert spaces to underscore. So if I run this, if you see, this is also fixed. So wherever space was there, we have the underscore. So I will assign it back to df dot columns. Okay. So this task is also done. So if I look at the data again once, df dot head 5, we have all the column names sorted. So we handled both the things. We handled the null values so that those values come as none, and we handle the column name also, right? Now what we have to do, we have to drive some new columns, right? So currently we have three columns. If you say cost price for each order, right, list price and discount percentage. So how much discount? So this is the cost to company that they are buying at this price. This is the MRP, right? On MRP they are giving this discount, right? So we have to drive a discount column. So this is a percentage. We have to drive a discount column of exact value, how much discount we gave. So list price is 260, multiply by 0.02, because 2% it is, right? 0.02 will give me that much discount we gave. So what we have to do, we have to say df and the list price, right, into df discount percent, right, divide by 100 or multiply by 0.01, same thing, right? So if you see, 260, 2% of 260 is 5.2, so we are getting 5.2. So I will put it in a new column, df discount. This is the exact discount that we are giving, right? So this is done. This is going to create a new column, df discount, with this value. So if I look at the df again once, we have the discount column created, 5.2, 21.9, 0.5, right? The next thing is, we have to have a sell price, right? What is the sale price? List price minus the discount, right? List price minus the discount. So I will say sale price equal to list price, right, minus whatever is the discount we are giving, exact discount, right? So if I just run this, and we have the sale price as well. So 260 minus 5.2 discount, 254.8. So this is also done. Next thing is, we have to find the profit. What is the total profit? So I will say profit equal to, now profit will be df cost price minus sale price, right? So let me write it. So this is my sale price minus cost price, right? This is the cost price here. And this will be my profit, because I am selling at this price after discount, and this is my cost price. And if I look at the df now, we have the profit that we bought it at, company bought it at 240, sold it at 254.8, so $14.8 or rupees, whatever. This is the profit. Okay, so we derived all the columns which are required. Now at this point, I think cost price, list price, and discount percent column are not required. We can do all the analysis using these three columns. So what we will do, we will drop these columns, whatever is not required. Okay, so we are going to drop those columns. Before that, one more thing is, if you look at the data types, okay, we will do it later, but before that, we have to convert order date to date. So if I show you the data types, you see order date is object, though it look like a date only, YYMMDD, but if you see, this is an object data type, right? It shows you data type of each column. But what we want to convert it into a date, right? Because when we load into SQL, it should go as a date, not a string. Because if it go as a date, we won't be able to do all the operations, right? So what we will do, we will use a to date time method of pandas. In this, we have to pass the column. So df order underscore date, right? We have to give it in single quotes, and I have to tell the format, that my string is in which format, right? So my string is in YYMMDD. So because it is four letters, I have to give percentage y, and then percentage m in small, percentage d in small, and there is a hyphen in between, right? This is the format of my string, and I'm saying this is the format converted to date. So if I run this, you see this is showing me a data type of date time, and I will assign it to order date on the original data set, right? It'll run this, and this is done. So if I look at the df now, it is fine. Let's look at the d types, right? So this is a date time now, right? This is a date kind of column. Okay, now we will drop those three columns. As I said, we don't need those three columns, right? We are going to drop them. So I will say df dot drop, and I will say columns. So if you want to drop rows, you have to say index equal to an index values. Here we want to drop columns, so I'll just pass all the columns. So list price is not required. List price, and we don't want a discount percentage and cost price, right? So cost price also we will remove it, and we are going to remove discount percentage. Okay, so these three columns are not required. Okay, so I'm going to drop it. Now when I drop it, what will happen, it will show me the data after dropping the column. So if I run this, you see those three columns are not there, list price, cost price, but the df is in the actual data set, it is still there. It is not dropped. So if you see, all the columns are there, list price, discount percent, cost price, right? So what we have to do, we have to say that in place equal to true. We have to pass this argument, which means in the data set only make this change, drop the columns. So it will not return anything, it will just drop it. And if we see, now we don't have, right? So you have to use this in place equal to true. Okay, so this is what we have done so far. We have done all the cleaning, new columns we created, dropped all the columns. The next thing is, we want to load this data into SQL server. Okay, so we are going to load this data in SQL server. For that, I will be using some of the libraries. So let me copy that. So these are the libraries I will be using. So let me copy. Okay, so pandas is already there. I'll just remove it. So I'm using SQL Alchemy to connect to my SQL server. So this is my SQL server, right? This is my SQL server. So I will connect to SQL Alchemy, and let me delete this table. Okay, so this is my SQL Alchemy, and this is my SQL server. So if you go to the SQL server and connect on properties, so this is my server, Ankit SQL server. So I will be connecting to this server, right? And if you look at this code, here I am passing that this is my server. I am saying MS SQL. So I'm creating a connection using this create engine method of SQL Alchemy. In this, I have to say this is my MySQL, MS SQL. If it is MySQL, you have to pass MySQL. If it is Postgres, you have to say Postgres. Then you have to pass the server name, then master means which database you want to connect. So this is the default. There are many databases. This is the system database master, so I will connect to this, and this is my odbc driver for sql server, right? So these things you have to pass. If you don't know what is your odbc driver of sql server, you can just go there, odbc data sources, and if you look at the SQL Server, it shows you ODBC driver for SQL Server. So when you install SQL Server, it will be there. And if you're using any other database, you will be able to find it out. Just try to Google it if you don't find it, right? So these things you have to pass, right? This is a Windows authentication, so I don't have to pass any username password. And then I will say connection equal to engine.connect. And if I run this is now connected, right? So I have a connection created. Now what I will do, I'm going to load the data into sql server. So for that, this is the command. So I'm saying df is my data frame dot to sql. So I'm saying load this data into sql. In sql, table name will be df orders. This will be my connection, right? Because I need connection information to where we have to load the data in which sql server, right? Index equal to false. So what happens when you create a data frame, this index column is created 0 1 2. I don't want this column in my table, I want from order id only, right? So for that, I'm saying index is equal to false, and I'm saying if exists, replace. It means that if table is there, replace it. It what it will do, it will drop and create the table. So currently this df orders table is not there. So when I use replace option, it will create the table automatically. Okay, so we will see. So I'll just run this. It will take few seconds. So it is just about to be done. Yes, it is done. So if I go to the SQL Server and select, I'll just refresh it. So df orders is not there currently. You see, df orders, there is no table. After c there is e. I'll just refresh it. If you see, df orders is created now. So I'll say select star from df underscore orders. So this data is created, and you see these values are coming as null. That is what we wanted, right? Water is not available, come as null. Otherwise it would have come as not available, unknown, which is not a good thing. Order date is coming as date, or it is as a date time actually, but we don't have a time attribute, but we can use it. Okay, and then we have everything in a lowercase underscore. So this data is clean. Now we can do analysis. There is one problem still. So the problem here is, if you look at the df orders and columns in this table, if you see, the data type is not proper. Everything is coming as chip mode, for example coming as varchar max, right? So it will take more memory. Similarly, quantity is coming as big int. We don't want as big int is enough, right? So we have to do some changes for this. So the best practice is, don't use this option if exists replace, because the pandas will create a table with highest possible data types. So varchar max, right, big int. So what you should do, you should create the table yourself. Once you have this ddl, you can modify it and create a table, and instead of replace, say append, which means it will append the data into the table, right? So it will not create the table, whatever table is there, and it will append in this. So what I will do, I will drop this table now, drop table, right? And I will use this ddl to create the table. Okay, so I will create an empty table using this, right? So how many columns are there? We can check: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 16 columns are there, right? And in our data also, if I look df dot columns 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So this seems to be fine. So we have created this table now. Command done, table, empty table created. Now instead of replace, I am saying append, and run this again. Okay, so now it will just load the data. It will not try to create the table because we are saying append. Okay, so if I just remove this, let me remove this, and I will say select star from df underscore orders, right? So data seems to be fine, right? Everything is fine. And if I just refresh it, the column type is also fine. We have a primary key. Order date is date. Instead of date time, we made it date, right? And city and all those columns are proper varchar 2050, whatever is not needed, quantity int. So we decided that what data type we want, and then we loaded the data. Okay. So this first exercise is completely done. Basically, it is kind of a ETL project. We extracted data from Kaggle API. We did data cleaning, transformation in Python, and then loaded into SQL Server. Now we will do some data analysis. Okay, so let's start with some of the questions. So here are the questions, right? We will tackle one by one all the questions. So the first question is find top 10 highest revenue generating products. Okay, if you have seen the video till here, please do like the video, subscribe to the channel, and share with other people because it takes a lot of effort to create these kind of videos. Okay, so the first question is find top 10 highest revenue generating products. So we have to find which products are sold most based on the product ID, right? And the sale price. So this is my sale price, right? So based on the sale price, I have to tell which are the highest selling product, right? Top 10. So for that, first I have to get for each product what is the total sales. So I will say from df underscore orders, and I will say product underscore id, comma, sum of sale price, right, as sales, group by product id, right? So let's run this. So we have got the sales. Now I will say order by sale price, or I can use sales because in the order of execution, order by runs after select. So I can directly use this alias. So these are my in descending order, right? I need to do in descending order. So if you see, these are my top 10 products, right? By sales. These are my top 10 products. So to get the top 10, I will say top 10. Right, so this top 10 runs at end. That is when the order of execution is important, because after select, order by is will run. So you are able to use this alias. You also know top 10 will run at the end after order by. So we are doing order by sales descending and then top 10. So we are getting top 10 product with highest revenue generated. So these are my product with highest revenue. Okay, so this answers my first question. Let's move on to the second question. So second question says top five highest selling products in each region. Now I need, this is the overall, right? So I have different regions. So if I say select distinct region from df underscore orders, right? So there are four reasons. In each region, which are the top five highest selling I need, right? This is a very common interview question as well, right? What I will do here, let me copy this. I will introduce region as well. So I will say, let me remove this. Within each region, give me the sales of each product. So what is the, in each region for each product, what is the total sales, right? So I'll just take this. Okay, and reason, group by reason and product id, order by reason and sales. Okay, so let's do this. So now I got, so because I'm doing order by reason and sales, so for central region these are the top five products, right? Because sales in descending order, so first it is sorting on reason, then on sales. So these are my top five products, right, in central. This is what I want. Similarly for next region, right? So for example, east region, let's go little down. Here also these are my top five products, right? So these products can be different in different regions, right? So I need total 20 records, 5 records for each region. So what I have to do, I have to generate a rank, right? to generate a rank, what I have to do, I will say I will use it as CT with CT as, right? And let me remove this order by for now, and I will say select star from CT, right? And here I will generate a row number or rank, any function you can use for instance, over partition by region, because in each region I want a rank separately. Order by sales descending, right? So if I run this now, sorry, I have to close this as Rn. Okay, so if you see in central region, right, we got whatever the top five, they got rank from 1 till 5, right? Similarly, for east region, right, if I go to east region, the ranking will start again because I have done partition by region, right? Which means for each region, it will again start the ranking. So again, it is starting from 1. So if you see, these are the lowest, which has no sales almost 0, right? So if you see in east region, these are the top 5 products, right? So what I have to say now, I will say select star from this, or you can again create a CT where I have to give a alias for subquery Rn less than or equal to 5, right? So for each region, it will give me top 5 products by sales, right? So top 5 for central, top 5 for east, top 5 for south and west. So we have 20 records. This is this is the answer to the second question. Okay, let's move on to the next question. Next is find month over month growth comparison for 2022 and 2023 sales. So currently the data we have is 2022 and 23. So we can check it. Select year, order date from orders. Right? So we have 2021, 2019, we have others actually. Sorry, not orders, DF orders, my bad. And let's do distinct. Okay, so if you see, we have 2 years of data, 2022 and 23, right? So what we want to do comparison for 2020-23 for each month. So in this way, January, right? In January, what is the sales in 2022 and what is the sales in 2023? This is how we want data. Similarly, it will be for Feb. So we want to kind of pivot the data, right? So for that, what we will do, so we need year first of all. So I will get year from order date, right? Or there is another way, or let's do this way. So we have the year, right? And apart from this, what we need sales, right? So I will say, what is the column name? Sale price, right? Okay, so for each year and month, right, I need month as well, right? Order date, sale price. What I will do, I will do a aggregate and say as sales. So first I need data at year and month level, right? Then only I can do whatever is required. And this is grouped by this. Okay. So if I run quickly this, we have got for each month, year month combination. Let me do order by as well. Okay. And let's call it order year as order year and as order month, right? And if I run this, okay, so this is my 2022 order month 1. This is the sales, right? Similarly, till 12, and then from 2023 1 to 12. Now, what I have to do for each month, I have to put in separate columns. So for order month 1, 2022 sale is this, and for again for order month 1, 2023 sale is this, right? I have to put in different columns. So I'll again use the CT here with CT as, right, this is done. Now I will say select from city. So what I want month wise. So I will say order month for each month, right? And say group by order month, right? For each month I want one row, but I want two columns. So I will say case when order year equal to 2022, then take sales, right? Else zero end, right? Similarly, I'll create one more column 2023, then sales and column. So if I run this without group by, what will happen without group by? Let me run this. Order by is not allowed in the subquery, so let's remove it and let's run this again. Okay, so I'm getting, if you see, for 9, let me do order by order month, right? So for each month, I am getting two rows, right? First row is for 2022. So whenever 2022 is there, this is the row, and this will be zero, right? So this is my 2022 sales basically. In 2022 sales, wherever the year is 2023, it will be zero, right? So if I take order year also, it will be more clear. So if you see for 2023, the first column is zero, right? This is zero because first column represents 2022 sales, right? This is 2022 as sales 2022, right? And let me rename this as well as 2023, and one more time let's run it final time. If you see, this is row of 2023. So in this 2022 sales is 0 and 2023 sales is there, right? So there are two rows, but only in one row the value is populated, right? So what I will do, I'll just say sum, so that it will aggregate and give me one row only for each month, right? And I will do group by as well, and let's run it for the one last time. Okay, uh some error. Hmm. Okay, order here is not required now. Okay, so we got order month 1, sales for 2022, 2023, and similarly for all 12 months, right? So this is what we wanted as part of this question. Okay, let's move on to the next question. Next question says, for each category, which month had highest sales, right? So each category, how much is the sales, month-wise sales? First calculate that. So select star from df underscore orders. Within each category, we have to find that, for example, for technology, there are 24 months, right? From 2022 to 2023, there are 24 months. So which month had the highest sales, right? Similarly, for furniture, which month had the highest sales? So we have to find that month, right? Now, month will go with along with year because we have the year, 2 years of data, right? So if we don't consider year, it will merge the data. That will be wrong. So what we have to do, we have to drive a year month function, right? So we have to get this data in year month format. So one way is we can use this format function. So we can say format, or we can use two columns as well for year and month separately, but this is a good column actually, good function. So I'll say order date, and then I have to pass the format here, right? So I will say, one second, format, and here yy mm. So I'm saying format the date in YYMM format, right? So if I run this, you see it is coming as 2023-03, right? 2023-08. So I get year month combination. The date is not there. Now I can directly aggregate data on this. So I will say as order month, order year month, let's say, right? And then sum of what? mm, sale price as sales. Now I need for each category, so I should have category also, right? And this will be my sum of sales and group by, let's take this category and this, right? So I got data at category and month level, right? So for each category, let me do order by as well to make it more clear. So if you see for furniture, right, this is the sales for first month, 2020-01, 2, 3, 4. Similarly for 2023. Right, now we have to find which month saw the highest sale for each category, right? For each category. So I should have three rows, one for each category. So again, I will convert it to a city, right? So this is my city. Again, I have to do a rank. Select from city, right? Star, comma, row number over, again partition by category, right? Because for each category I want order by sales descending, because I want to see which month had highest sales, right? So if I run this, order by is not required, again not allowed in subqueries or cities. Okay, so if you see for furniture, highest selling month was 2022 10, right? This is the sales. Similarly, if we go down for office supplies, the highest selling month was 2023 02. Similarly, for technology, it is 2023 10, right? So what we have to do again, I can just say select star from, as I said earlier, you can create even a CT and alias where rn equal to 1. We want just highest selling month, right? So this will give me the result. Okay, so these are the highest selling months for each category. I hope it makes sense. Okay, let's move on to the last question. Now last question is, which subcategory had the highest growth by profit in 2003 compared to 2022? So it is saying which subcategory saw the highest growth in profit, right? So we have done some year wise analysis here. Let's use this. So I'll just go here, this one, right? So let me copy this. I'll just do some changes in this. Okay. So now they are talking about subcategory, first thing, right? So what I will do, I will introduce subcategory here. Okay. Sub underscore category. Is it wrong? Okay, it is fine. So okay, now here we are not concerned about month, so let's remove the month. We want only year wise, right? So let's subcategory year, and here also let's remove month, right? Because we need to see which subcategory saw highest growth, right, in 2023 compared to 2022, right? So for each subcategory I have to get the growth number for 2023 compared to 2022. So let's do this, and again I will use the same thing, subcategory, right? So for each subcategory I will get this number. So let me run this quickly and show you what I am trying to do. Okay, so if you see for each subcategory, there are 17 subcategories. I got 2022 sales, 2023 sales, right? Now I just need to see which category, subcategory has the highest growth, right? So for that, let me create this as a CT2 as, okay, and I will say select from CT2, right? Now I need to find the growth. So how I find the growth? I will say sales of 2023, right, minus sales of 2022 divide by sales of 2022 into 100, right? Divide by Sales of 2022 into 100, right? So if I just run this, it will give me the growth percent. If you see, this is giving me growth percent. So for example, from 77,000 to 83, it is 8% increase. Here if you see, sales has decreased. For art again it is decreased. For binders it is increased. So this is giving me the growth percentage. So I can use this in order by, so that I can use this for filtering. Order by this in the descending order, because we want highest growth subcategory, right? So let's run this, and this has the highest growth in terms of percentage, right? From 16,000 to 28,000. And now I can just say top one, because I need the highest growth subcategory, the top one category subcategory, and this will give me the result. Okay, so supplies saw the highest growth in terms of percentage. If the question is without percentage, then you don't have to do this, right? Without percentage, answer can be different. So percentage wise, it is 80%. So if I just remove this, if I just see plain growth, right? So this, the answer can be different. It might not be supplies, right? It will be different. So you have to be careful about the question. So this is machines now. Machines saw the highest growth of 35,000. It depends on what is the question, you have to do accordingly. Okay. So this is your end-to-end project. I hope you liked it. Please do subscribe to the channel, like the video, share with your friends. We have done everything from Kaggle API to downloading, cleaning, pre-processing, and then loading to SQL Server and doing the data analysis. You will find the link in the description box to get all the documents, all the codes. Thanks for watching. Have a good day.